Okay, so this is Unit 4 for the AP Physics, Electricity, and Magnetism. And here we're going to focus on magnetic fields and start that conversation moving into Unit 5, talking about electromagnetism. Okay, so in this video, we're just going to look at some of the basics behind magnetism. For example, the first thing that you need to realize is that magnetism is not electricity. Okay, they do share a lot of the same properties, but understand magnetism is not electricity. Okay. Now, magnetic poles and electric charges share some similar behaviors, but they're not the same. Okay. They do follow that rule of opposites attract, likes repel. So north and a north will repel each other, just like positive and positives repel each other. Okay. So again, just like electricity, magnetism is a long range force, which means that the force is you're going to feel it over a distance and exerts only by not touching the object, right? So it's just like electricity or the electrical force. Um, Magnets will only exist with two poles, right? And go back to middle school and elementary school, we call them the north and the south, right? Um, and so we call this, uh, these are called magnetic dipoles, right? Because the prefix di means two. Okay, because they always exist with two poles. You can never have what is called a monopole or a monopole. Okay, because even when you break it, like, oh look, I've got two pieces. I just broke it. I broke it right down the middle. So this side should be south. This side should be north. That's not how it works, right? So everything realigns so that you get a north at one end and a south at the other end. Okay, um, so the two poles exert repulsive forces on each other, and the opposite poles attract, right? Just like we talked about with electricity, opposites attract, like repel. So if a magnet is broken, the end always forms the different. So the end will always form the different poles because they can only exist as dipoles, right? We just mentioned that. Um, so if I had a magnet that's north south, and I broke this magnet, so I have two pieces. Okay, what you'll find is that they will rearrange themselves so that you get a north and a south pole. Okay, they always exist as magnetic dipoles. Okay, the poles of a bar magnet can be identified by just simply taking a compass and passing it near through it. But the poles of other magnets need to be found by using a bar magnet. So if I have a bar magnet, right, I can find the pole by just simply bringing a compass by it. But if I have a horseshoe magnet, it's kind of hard to figure out which side is north, which side is south. So what I do is I take my bar magnet, right? And if it attracts, right, if I know this is the south end and it attracts, that makes this the north pole, this the south pole, right? And we can just check it by simply flipping it and seeing if it pushes away or attracts. Okay, materials that are attracted to and other magnets are called magnetic materials, right? It's just kind of common sense. In fact, the most common magnetic material is iron. So if you had a nice little magnetic field demonstrator, there's iron filings inside. Um, and then so magnetic materials are attracted to both ends, right, of the magnet. So there's no distinction between a north and south in the magnetic material. It's just attracted to it all. Okay. So that's just, again, this is probably just some review for basic magnetism. In the next video, we're going to look at specifically the magnetic field that is generated. And so and then eventually we'll come and talk about how it's related to magnetism.